How does 5G put aircraft in danger? An electrical engineer explains. New high-speed cell phone services have raised concerns of interference with aircraft operations, particularly as aircraft are landing at airports. The Federal Aviation Administration has assured Americans that most commercial aircraft are safe, and ATT and Verizon have agreed to hold off on installing their new cell phone antennas near airports for 6 months. But the problem has not been entirely resolved. Concerns began when the U.S. government auctioned part of the C-band spectrum to wireless carriers in 2021 for $81 billion. The carriers are using C-band spectrum to provide 5G service at full speed, 10 times the speed of 4G network. The C-band spectrum is close to the frequencies used by key electronics that aircraft rely on to land safely. Here's why that can be a problem. Wireless signals are carried by radio wave. The radio spectrum ranges from 3 Hz to 3000 gigahertz and is part of the electromagnetic spectrum. The portion of the radio spectrum that carries the signals from your phone and other wireless devices is 20 kilohertz to 300 gigahertz. If two wireless signals in the same area use the same frequency, you get garbled noise. You hear this when you are midway between two radio stations using the same or similar frequency bands to send their information. The signals get garbled and sometimes you hear one station, at other times the other, all mixed with a healthy dose of noise. Therefore, in the US, the use of these frequency bands is tightly regulated by the Federal Communications Commission to ensure that radio stations, wireless carriers and other organizations are assigned lanes, or frequency spectra, to use in an orderly fashion. Modern airplanes use altimeters, which calculate the time it takes for a signal to bounce back from the ground to determine a plane's altitude. These altimeters are a vital part of automatic landing systems that are especially useful in cases where there is low visibility. So, if an altimeter interprets a signal from a wireless carrier as the rebounded signal from the ground, it may think that the ground is closer than it is and prematurely try to lower the landing gear and do the other maneuvers that are needed to land an aircraft. If interference with wireless carrier signals corrupts and garbles the altimeter's radio signals, the altimeter may not recognize the rebounded signal and thus be unable to figure out how close to the ground the plane is. The portions of the radio frequency spectrum used by airplanes and cell phone carriers are different. The problem is that airplane altimeters use the 4.2 to 4.4 GHz range, while the recently sold, and previously unused, C-band spectrum for wireless carriers ranges from 3.7 to 3.98 GHz. It turns out the 0.22 GHz difference between the signals may not be quite enough to be absolutely sure that a cell phone carrier signal will not be mistaken for or corrupt an altimeter signal. The telecommunication industry has argued that the gap of 0.22 GHz is enough and there will be no interference. The airline industry has been more cautious. Even if the risk is very small, I believe the consequences of a plane crash are enormous. Who is correct? The chances of such interference are very small, but the truth is that there isn't much data to say that such interference will never happen. Whether there will be interference depends on the receivers in the altimeters and their sensitivity. In my view, there is no way to ensure that such stray interfering signals will never reach altimeters. If the altimeters can register the stray signals as noise and filter them out, then they can function correctly. Upgrading aircraft altimeters is a costly proposition, however, and it's not clear who would pay the cost. The FAA has been testing altimeters and clearing ones that can be relied on in the near future. ATT and Verizon have agreed to not put up 5G transmitters and receivers near the 50 largest airports for 6 months, while a solution is being worked out. This has averted a major crisis in the near term, but it isn't a permanent solution. Moreover, regional airlines and rural airports remain at risk of interference. Is a professor in the College of Information Sciences and Technology at